How did a single asteroid wipe out the dinosaurs around the globe? It's over 7 miles wide, and it travels at 40,000 miles per hour. And the crater's dimensions tell us something else. 30,000 cubic miles of rock are displaced here. Vast amounts hurled into the atmosphere, setting off a devastating chain of events.
It blows a hole in the ground about the size of the state of Massachusetts. Now, all that rock, it gets pulverized, thrown up through the Earth's atmosphere, starts to orbit the planet. And when that rock comes back in, it's got a tremendous amount of potential gravitational energy. It heats up the atmosphere to toaster oven or pizza oven temperatures, frying everything that doesn't have a place to hide.
Almost every living creature within 600 miles is killed by this deadly fireball. But those farther away do not escape. But the asteroid strike becomes a truly global disaster for one specific reason: where it hits Earth. This part of the planet contains rocks high in sulfur. On impact, the sulfur is vaporized and blasted high above the Earth. The asteroid hits deep water here, absorbing some of the impact, and 30 minutes later, the ocean rushes back in. Water vapor from this tsunami combines with the sulfur to form sunlight-blocking gases in even larger quantities. Deep beneath the tropical waters of the Gulf of Mexico lies a seething history of piracy, slavery, and bitter conflict. Imagine if we could empty the oceans, letting the water drain away to reveal the secrets of the seafloor. Now we can. Using the latest underwater scanning technology, piercing the deep oceans and turning the accurate data into 3D images. This time, why did a deadly German U-boat end up at the bottom of the ocean, off the coast of New Orleans? 66 million years ago, dinosaurs roamed the Earth. Then, in a geological instant, they are wiped out around the planet. Experts have offered many answers, but only one is widely accepted.
By far the leading explanation is that an asteroid hit the Earth 66 million years ago and unleashed hell on Earth and took out the dinosaurs and 75% of life.
Scientists scour the planet, looking for evidence of asteroid strikes. But none of the impact craters that they find are big enough and of the right age to be the culprit. Then, in Mexico's Yucatan Peninsula, discovers that many of the cenotes are linked through deep subterranean channels. But that's not all. They also display a remarkably similar structure. When seen from above, an extraordinary picture begins to emerge. The cenotes form an outline. It looks like the rim of a gigantic crater. The most likely explanation is that a massive asteroid strike reshaped this region, and then the sinkholes formed in fault lines around its edge. Could this be the crater that's linked to the death of the dinosaurs? Today, millions of years after it was created, the heart of the impact site lies concealed, not just under the water, but under several thousand feet of sedimentary rock. The only way to calculate its age and see if it dates from the demise of the dinosaurs is to analyze rocks from the crater itself. In 2016, an international team of scientists drilled down from this specially adapted oil platform. The team hits a layer of melted rock, indicating an asteroid strike. And samples confirm that the rocks are 66 million years old, the exact moment when the dinosaurs died. Next, the team analyzes the rocks to calculate the asteroid's power. Comparing their data to that generated by nuclear bomb tests. Using this data, it's possible, for the very first time, to create a 3D visualization of the crater, now hidden deep beneath the Earth, and discover how a single asteroid can wipe out dinosaurs around the globe. 66 million years of geology must now be rolled back, draining away layer upon layer of sedimentary rock, until the impact site begins to emerge. A sight that no living creature has witnessed for 66 million years. The crater is immense, over half a mile deep and 120 miles wide. Around its edge towers the outer rim, formed by rock ejected from deep within the Earth's crust. Now, by studying the crater's profile, it's possible to determine the size and speed of the asteroid.